Good morning students. In this video we are going to see unit 6 light from page number 73 to 75. Learning objectives. Identify the direction of bending when light passes from one medium to another. Predict whether light will be refracted or undergo total internal reflection. Now let us see refraction of light through one activity. See this activity. Put a sprite pencil into a tank of water or beaker of water at an angle of 45 degree and look at it from one side and above. How does the pencil look now? The pencil appears to be bent at the surface of water. See this diagram. Now we have to immerse a pencil in a beaker containing water. Now we have to see the pencil, appearance of the pencil through one side or above the surface. Now here we have to see that the pencil appears to be bent at the surface of water. This activity explains the refraction of light. This activity explains refraction of light. Now what is called refraction of light? The bending of light rays when they pass obliquely from one medium to another medium is called refraction of light. So in previous activity the light ray falls from air to water. So when they travel from air to water, the bending will take place. When the bending of light ray takes place? When they travel from one medium to another medium. So it is called refraction of light. So a pencil travels from air to water, so the bending of pencil takes place. So it is called due to refraction. So what is called refraction? The bending of light rays when they pass obliquely from one medium to another medium is called refraction of light. Now why the bending of light takes place? While they travel in different medium, the light rays get deviated from their original path while entering from one transparent medium to another medium of different optical density. See this diagram. Pencil travel from air to water. So when they travel from one transparent medium to another transparent medium, it gets deviated. So the pencil look like bending. So it gets deviated. Why it gets deviated? Because due to different optical density of the medium. So air having different density and water having different density. So due to this different density, the light rays get deviated. This deviation means change in direction in the path of light is due to change in velocity of light in the different medium. Why this deviation takes place in different medium? It is due to the change in velocity. Air having different velocity and water having different velocity. So both the medium having different velocity, so the deviation will takes place. The velocity of light depends on the nature of the medium in which it travels. Already I told in previous point, that is the velocity of light depends on the nature of the medium, air and water. So air having different nature and water having different nature. So depending upon the nature of these two medium, the velocity of the light depends. So the velocity depends on the nature of the medium in which it travels. While they travel in glass, it having different velocity. So while they travel in air having different velocity. So the velocity of light is more in a rarer medium. Where the velocity is more? In rarer medium than in a denser medium. What is called a rarer medium? Rarer medium means low optical density. What is optical density? The intensity of light falling upon a material is called optical density. So velocity of light is more in a rarer medium than in a denser medium. Denser medium means high optical density. Where the velocity of light is more? In rarer medium. Where it is less? in denser medium. All these points are very important for 1 mark questions. Now let us see the refraction of light from a plain transparent surface. When a ray of light travels from optically rarer medium to optically denser medium, it bends towards the normal. When a light ray travels from rarer medium to denser medium, it bends towards the normal. Which one bends towards the normal? Refracted ray. Refracted ray bends towards the normal. See this diagram. The incident ray travel in rarer medium. Air is the rarer medium. And then water is a denser medium. So when this incident ray reach the denser medium, it bends towards the normal. So while we measure the angle between incident ray and normal ray and refracted ray and normal, which angle is greater? Angle of incidence or angle of refraction? Angle of incidence is greater than the angle of refraction. When a ray of light travels from rarer medium to denser medium, it bends towards the normal, and then the angle of incidence is greater than the angle of refraction. Now in the second case, when a ray of light travels from an optically denser medium to an optically rarer medium, it bends away from the normal. When a ray of light travels from denser to rarer medium, it bends away from the normal. See this diagram. A light ray travels from water to air. While they travel from water to air, it bends away from the normal. It bends away from the normal. Now when we measure the angle of incidence and angle of refraction, which one is greater? Angle of refraction is greater than the angle of incidence. So these are very important point. When the light ray travel from denser to rarer medium, angle of refraction is greater than the angle of incidence. And then third one, a ray of light incident normally on a denser medium, it goes without any deviation. See the diagram. Here air and air, both the medium are air. So when they travel in same medium, there is no any deviation. Already in definition we saw that the refraction takes place when the light ray travel from one medium to another different medium, but here both the medium are same, so there is no any deviation and there is no refraction. Now the laws of refraction of light. Laws of refraction, also known as Snell's law of refraction, are given below us. This law of refraction, also known as Snell's law. What is Snell's law? Laws of refraction of light is known as Snell's law. Now let us see the first law. The incident ray, the refracted ray and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. Incident ray, refracted ray and normal, all these three, incident ray, refracted ray and normal, all these three lie at the same plane. Interface, what is interface? Interface means where the two medium meet, two surfaces meet, is called interface. So what is first law? Incident ray, refracted ray and the normal to the interface of two transparent media. What are the two transparent media? Air and water. Interface of two transparent media at the point of incidence, where both the rays meet, is called point of incidence. All lie in the same plane. Now second law, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant for a light of given color and for the given pair of media. So when we have to measure angle of incidence, angle of I and angle of R, angle of I and angle of R is a constant for a light of given color, whatever the color may be, blue, red, violet, whatever the color of light may be, it is a constant for the given pair of media. The given pair of media means air, water, glass, oil, whatever the medium may be. So sin I by sin r is constant. If I is the angle of incidence and r is the angle of refraction, then sin I by sin r is equal to constant. It is very important law. Ratio of the sine of angle of incidence to the sine of angle of refraction is a constant for a light of given color and for the given pair of media. That is sin I by sin r is equal to constant. Now what is this constant? That is sin I by sin r is equal to constant. Now what is this constant called? This constant is called the refractive index of the second medium with respect to the first medium. Suppose if the second medium is water and the first medium is air, means this refractive index of the second medium with respect to the first medium, that constant is called refractive index of second medium with respect to the first medium. It is generally represented by the Greek letter mu. See this letter mu. So here 1, 2 represents the medium. Mu is the refractive index. So the refractive index of the second medium with respect to the first medium. Now this refractive index has no unit, as it is the ratio of two similar quantities. First medium also having the same unit, second medium also having same unit. So both the unit are get cancelled. So there is no unit for refractive index. The refractive index of a medium is also defined in terms of speed of light in different media. We have to define this refractive index by using the term speed of light. In previous cases, we have to define the refractive index in terms of the angle. Now here we have to measure in terms of the speed of light. Mu is equal to speed of light in vacuum or air by speed of light in the medium. So here we have to take air only as a first medium. Second medium we have to take any medium, water, glass, kerosene, mercury, whatever the medium may be, it is our choice. We have to take any medium as a second medium. So mu is equal to speed of light in vacuum or air by speed of light in the medium. In general, 1 mu2 is equal to speed of light in medium 1 by speed of light in medium 2. So understand the formula. Mu is having two formula. Mu is equal to speed of light in vacuum by speed of light in the medium. Already we saw one formula, sin I by sin r is equal to mu. So mu having two formula. Total internal reflection. What is total internal reflection? When light rays travels from denser medium to a rarer medium, it gets refracted away from the normal. When light ray travels from denser to rarer, it gets refracted away from the normal. So while the angle of incidence in the denser medium increases, the angle of refraction also increases. So when angle of I increases, angle of R also increases. It reaches a maximum value of R is equal to 90 degree for a particular value. Up to where they increases, up to angle of I and angle of R increases up to R is equal to 90 degree. So now this angle of incidence is called critical angle. What is called critical angle? When the angle of incidence in the denser medium increases, the angle of refraction also increases and it reaches a maximum value of R is equal to 90 degree. For a particular value, this angle of incidence is called critical angle. See this diagram. Now here first angle of refraction is 0 degree. Afterwards see here R is less than 90 degree and here also R is less than 90 degree. While it reaches R is equal to 90 degree, there is no refraction. Okay. Now this angle is called as a critical angle. This angle is called as a critical angle. The angle of incidence at which the angle of refraction is 90 degree is called critical angle. So at R is equal to 90 degree, what is the angle of I? That value is called critical angle. If R is equal to angle of R is equal to 90 degree, when we measure the angle of I, Suppose it may be 100 degree or 60 degree. That angle is called as a critical angle. The measurement of angle of I when the angle of R is equal to 90 degree is called critical angle. At this angle, the refracted ray grazes the surface of separation between the two media. So, at this particular angle only the refracted ray spread on the two medium. When the angle of incidence exceeds the value of critical angle, the refracted ray is not possible. That is, when angle of I is greater than the critical angle, there is no refracted ray. Since R is greater than 90 degree, the ray is totally reflected back to the same medium. When the angle of R value is greater than 90 degree, then what happens? The ray reflected in the same medium. See this diagram, R value is 90 degree. So, the ray bend in the water only. When less than 90 degree, the refracted ray takes place in the air. When R is equal to 90 degree, there is no refracted ray, it spread on the medium. When R is greater than 90 degree, the reflected back to the same medium. This is known as total internal reflection. Now, this total internal reflection takes place in nature. First, we have to see the mirage. On hot summer days, patch of water may be on the road. Sometimes we have to see some water drops on the road. This is an illusion. In summer, the air near the ground becomes hotter than the air at higher levels. When we see the air near the ground becomes hotter. So, when we reach the air at a higher level is cooler. So, hotter air is less dense and has smaller refractive index than the cooler air. Which one has less dense? Hotter air. So, in summer, the air near the ground becomes hotter than the air at higher levels. So, hotter air is less dense and has small refractive index than the cooler air. See this diagram. Here we have some water on the road. It is due to illusion. Optical fibers. What is optical fibers? Optical fibers are bundles of high quality composite glass quartz fibers. Each fiber consists of a core and cladding. What is called core? It is the most essential part or the very center part of this object. Core is a center part of the object. Now, what is cladding? Cladding is a covering or coating on a structure of this material. When we give a cover or coating to this core is called as a cladding. Now, the refractive index of the material of the core is higher than that of the cladding. The refractive index of the core is greater than that of the cladding. Optical fiber works on the phenomenon of total internal reflection. In this optical fiber, it works on the phenomenon of total internal reflection. When a signal is in the form of light, is directed at one end of the fiber at a suitable angle. So, in this fiber, when a light ray, when a signal falls in this one end of this fiber, it travel at one particular angle, and also it undergoes repeated total internal reflection along the length of the fiber. It depends upon the length of the fiber and finally comes out at the other end. Now, what is the purpose of cladding? The function of the cladding is to provide a lower refractive index at the core interface in order to cause reflection within the core, so that the light waves are transmitted through the fiber. The larger the core, if we have larger core, the more light that will be transmitted to the fiber. If we have larger core, the light transmitted also more to the fiber. Optical fibers are extensively used for transmitting audio and video signals through long distances. What are the uses of these optical fibers? It is transmit audio and video signals through long distances, and moreover, due to their flexible nature, we have to use flexibility more in optical fiber. So, due to their flexible nature, optical fibers enable physicians to look and work inside the body through tiny incisions without having to perform surgery. So physicians use this optical fiber for surgery. Now, do you know an Indian-born physicist, Narendra Kapani, is regarded as the father of fiber optics. He was born on 31st October 1926. He was named as one of the 7 unsung heroes by Fortune in their businessman of the century. Thank you, students.